Robopapa.
Hey YouTubers, today I'm going to talk about voltage dividers and what are they useful for and like what we can do with that. As an example over here, already I have a voltage divider that really all it does is taking input from outside source and then it divides it to multiple voltages. That way I can have on my pref board different voltage levels depending on where I want it. I added like some regulator and some pot over here, that way I can actually change the input for the voltage itself. So what I'm thinking is we'll build something like that and we'll 3D print a case for it, that way we can actually take it with us wherever we need and reuse it. So let's get started. Okay, so what is voltage divider? It's basically it's just like its name. It's trying to divide a voltage. So if we'll take as an example, and we have the let's say we have the VN over here, and we'll have resistors in series, and over here will be the ground. The V out over here will basically be according to the formula of, if this is R1 and this is R2, the formula will be the R2 divided by the ratio or the sum of R1 plus R2 times the Vn. That will be equal to the V out. Which means that we're taking the ratio of R2 among these two resistors, and that will give us the V out. So for example, if we'll take that our Vn is 9 volts and R1 equal to R2, which let's say they will equal to 500 ohms, our V out over here will be equal to 500 ohms divided by 1000 ohms, which is R1 plus R2, times 9 volts, which means that it's 1/2 of 9 volts, which is equal to 4.5. Which means that if our resistors are the same, our V out will be half of our input, just like with this formula. So that can actually be useful for our voltage divider, like over here. We have a certain input and we're starting to divide it, and then we have like the same, like we have different outputs from one basically source. So knowing this formula, we can move on now to design the board. So I've attached the bottom base with the post for the PCB, as well as the binding post. So input will be from this side as the plus and the ground. Then we'll have output for 6 binding posts from the voltage divider with the 6 resistors. They are even resistors, that way the output will be divided evenly from each resistor. These resistors will basically be on the top over here, and we'll print the top section and attach the wires, and we probably will add a pod, that way we can control even the input value of the voltage, as well as an LED that will indicate if we have the power on or off from it. And then all of that will be controlled by the switch. So even if you're connecting the input over here, you can still control it with the on-off switch. So I'll start wiring everything and put the PCB in place, and we'll see how that comes out. So I built the custom PCB with all the resistors connected, and already have the binding post for the ground and the positive and the exit. Each one is connected to the binding post itself. Let me try to zoom in a little bit. There you go. And then the wires will basically go to the top module over here, where I have the pod to change the input voltage if we don't necessarily want the highest one. There will be an LED that indicates if the power is on and off, and then a switch to turn it on and off. And this will be a common ground for all the 6 binding posts that is the output. That way you can actually connect to it. So what I'm going to do, I'm going to finish now soldering all the wires to the switch, the pod, the common ground, and the LED from the input over here. So when I'm done with that, I'll show that progress. So here's the final product. Before I close it, I thought that I'll just show you how the connection goes. So we have the ground and positive that goes into the switch, which is over here, and then from the switch it goes into the pod, and then in the pod I have one that goes to the ground, continues the ground, the way I have common ground, and then I have an LED over here, so it's connected to the switch, ground, and power. Then from here it goes directly to the input rail, which this will give me the same input as what the pod gives me. And then from here it will start dividing them accordingly. So for example, if I get 9 volts in, I'll have 9 volts over here, 7.5 volts, 6, 4.5, 3, and then 1.5. So the resistors are similar, they're the same amount, so therefore they having the same ratio for all of them. So we'll do like a small test now, and you can see from here I have the ground, which is connected to the multimeter, which will turn, and then I'll use the multimeter positive to test it. I'll turn the power supply on 9 volts, which means that's what gives me to the input. You can see the LEDs already on, and the input is, and the output, the ground is right over here with the bananas. So now if I test the 9 volts over here, my multimeter will show 9 volts. If I'll go to the next rail, that should be 6.5 or 7.5, sorry. And then if I'll go to the next rail, that should be 6, etc. All the way down to the one over here, which will show me 1.5. So even though I have now an input of 9, I can move the pod. It's a little bit harder to do in one hand. So if you remember, I moved a little bit of pod. Now my input should be a little bit less. And there you go, now it's 3.8, even though I wasn't on the first one. So I'll close it and show you the final product after it's closed. So there you have it, the final product with the common ground, and then the input voltage on the ground and the positive, a switch to turn it on and off with an LED indicator, and then a pod to actually adjust the voltage the input voltage. And then we have 1 to 6 outputs, which with the equal resistance, so it will be the same ratio. So that's it. It's a very nice little box that you can use as a voltage divider to your projects. So as always, leave me comments below if you have any questions or any regular comments, and please don't forget to subscribe. It really helps. Alright, thanks guys.